Right, so sorry for the delay. Okay, so just now the file automatically closed up, so I think I need to maybe just show you a very simple solution here. So this is where we stopped just now, right? Okay, so why we are talking about the number of periods, and then you are having 4 periods in total, right? Okay, and then they said, what did they say? They actually want you to find out that exactly 3 of this period, then something happened. Okay, so the something happen means the probability at least one day with more than 20 cm of snow falling. This is what we have. Okay, then after that, they want you to calculate the probability y equals to 3. All right, therefore you should have 4C3 0.808 power 3. And then after that, you should have 0.912 power 1. Okay, then you should get the answer 0.405. Okay, so this is the example that we are having 2 stages of questions. That means the very first stage, they are talking about the number of days, and the second stage, they are talking about the number of periods. All right, so this type of question generally, if compared with the example that you tried previously, it will be slightly harder again. All right, and then after that, there's one thing that I need to remind you all here. Okay, so this is generally the solution, okay, for this example. All right, so you should have a look for this one. 0.808. I cut it short because originally it is a long value, right? Then I cut it short. Okay, so when I cut it short, I put it into my next calculation. So please take note, the 808 is not the final answer for these whole questions, right? Okay, so although you write 0.808 here in your solution, and also this one, but when you are pressing the calculator to get the answer, please make sure that you press out the long value. That means when I write, I only write 0.808, but when I type it out in the calculator, right? When I key in the calculator, I'm actually using this one. Okay, because the 808 is not your final answer. It is actually at the half part of your answer only solution. So you have to keep the long original answer, substitute it when pressing calculator, and get the answer in the most accurate way. Alright, some students say, I feel lazy, I don't want. Can. Then you try your luck. Maybe your final answer might not be the same as the final answer. Okay, so for this kind of question, you need to be extra careful. Alright, a lot of them will lose mark here also because they just keep the short value. But actually, this shouldn't be in the short value. You can write out in short, but when you press the calculator, please keep it long. Okay, so this is what you have for the two stages question. So just go and have a look back for example 18. Right? Okay, so example 18, as I mentioned just now, I will just leave it for you to try out on your own. Okay, so just a very quick discussion on this. Okay, so for example 18, okay, if you look at the question here, they said a box is chosen at random. Show the probability that this box contains exactly 6 milk chocolate eggs is this one. Okay, so for the first stage of question, they are talking about the number of eggs. So something happened means milk chocolate. All right, so you're exactly having 6 eggs. Then something happened. So what is the total trial or total eggs? You're having 12 eggs in a box. So the total number of trials should be 12 eggs. And then you want to calculate the probability x equals to 6. Okay, then when you proceed to the next example, okay, so they are talking about find the probability that at least 2 of these boxes. Just now they are talking about eggs, so now the second stage they are talking about boxes already, not eggs anymore. All right, so please go and figure it out. How can you write out and get the correct answer? All right, so for me, I'll give you this answer. Of course, this answer will be 0.223. Okay, so it's very simple. You just start with x is binomial distributed, 12, and then 0.48. So x is number of eggs. Okay, and then for y, you are having 10 boxes here. So what is binomial distribution? 10. And then what is the probability that you should put in here? You figure it out yourself. I don't want to let you know. All right, then you calculate the probability lah. So for part 1, the answer should be 0.233, sorry. And then the part 2, the answer should be 0.690. Okay, then this one will be 0.223. Okay, so maybe for your information, I should tell you like this. At least 2 of these boxes contain exactly 6 milk chocolate eggs. So actually 6 milk chocolate eggs probability, you already get it just now in the first part, which is 0.223. That's why I say this question is easier. All right. Okay, so you should actually put 0.223 here. Okay, so for this question, it's a bit different from the example 19 that we discussed just now. In this question, you can use 0.223 in your calculator. No need to give them the long answer. Just now you need to give them the long answer, right? But this one no need. Okay, why? Okay, so you no need to keep the long answer when in the question itself, they ask you to prove that the probability is equal to this value. So when they ask you to prove, that means you can straight away apply this in your calculation. Okay, like example 19, they didn't ask you to prove, right? Okay, so you have to keep the original long value. So I hope that you have roughly have the idea of all this. Okay, all these are very small details, but actually it will affect your final answer. All right, so please make sure you really take note on all this. All right, okay. So this is what we have for the 2-stage questions. All right, then in exam, not many questions are from this part, but generally you still need to know. Okay, all right. Then after that, I will still continue with the next smaller part. All right, so now for binomial distribution, we also need to know what is the mean and also the variance for it. Okay, so for mean and variance for binomial distribution is very, very simple. To get the mean for binomial distribution, you just take n times p. To get the variance for this binomial distribution, you just take np cubed. So these two are the important formula that you should know. Okay, np is the mean, np cubed is the variance. All right. Okay, so I have a look for example 20. Okay, here they said mean number of defective battery in supply of 20 is 1.6. So the mean is 1.6 for this question. So use binomial distribution. So this question they already tell you that it's binomial distributed. Calculate the probability that a randomly chosen pair of 20 will have more than 2 defective batteries. Okay, so maybe first I need to settle down this part first. Okay, so you know that it is binomial distributed. All right, so n is 20, but the p you don't know. Okay, but from first sentence here, you know that the mean is equals to 1.6. So what's the mean for binomial distribution? N times p. So you're having 20p equals to 1.6. And from here, you should be able to get your value of p. So value of p is what? Value of p should be 0.08. Okay, so now you have all the details on the distribution already. 20 and then 0.08. Okay, so what they want, calculate the probability that a randomly chosen pair of 20 will have more than 2 defective batteries. So we are talking about the number of batteries, more than 2 batteries defective. So when you calculate the probability, it should be x greater than 2. Then you continue with the step. This one very simple, put it as a revision for you. Then the answer should be 0.212. Right, so this is how we actually use the formula for mean in binomial distribution to answer the question. All right, so this is what we have for example 20. Okay, then now we can continue further to have example 21. Okay, wait, my file is loading again. All right. Okay, then we continue with example 21. Okay, so for example 21, I make a typo here, so I think you should change it. All right, so for this one, it should be x is binomial distributed with n and p. All right, okay, then now they say mean is 5, standard deviation is 2. Find the value for n and p. Okay, so mean is 5. So that means you're having np equals to 5. All right, So this is the first equation that you have. Alright, so standard deviation is 2. So standard deviation is 2. That means variance is 4. Okay, so what's the formula for a variance formula distribution? It should be N, P, and Q. So NPQ equals to 4. This is the second equation. Alright, so how can I solve this and get the N and P? You just solve simultaneous equation. Alright, but I want you to have a look for the whole equation here. NP is equals to 5, right? I would like to substitute the second equation with 5. So you're having NP is 5, also 5Q. Alright, because you're having 3 unknown here. So if let's say you don't want to do this and then you cannot get the answer. Alright, so you're having 5Q equals to 4, therefore your Q is 4 over 5. Okay, and then just now you know that what is the value for P then? P is 1 minus Q, right? So 1 minus 4 over 5. Therefore, your P is 1 over 5. Okay, so this is how I get the P. Then after that, how can I get the N? Then you get it from equation number 1. Okay, so from equation number 1, I will show out the answer for you, the solution for you, the step. Then you try to get and see whether N is equals to 25 or not. Alright, so all these kind of questions are quite simple. They just want you to apply the formula for binomial and also the variance for binomial. Okay, it's a very straightforward one usually. Okay, then now continue with example 22. Okay, so for example 22, they already tell you that X is binomial distributed with this value, and then they want you to get the mean and also the variance. Alright, so the mean and variance, I don't think that I want to continue for you already. So the value for mean that you get, this symbol EX is expected value of X, which is also the mean. Alright, you learned it in discrete random variable before. Alright, so they're having the same meaning. The EX is also the mean. If you get it correctly, the mean should be 3. And then for the variance, you get it equals to 2.1. Okay, then now what I want to discuss is part number 2. Alright, so for part number 2, they say mu minus sigma. X is between mu minus sigma and also mu plus sigma. Alright, so now for this binomial distribution, what's the value for mu? 3. What's the value for sigma? The standard deviation, it should be square root 2.1. And then mu is 3 plus square root 2.1. Okay, alright, then now, what is the value for 3 minus square root 2.1? You should get 1.55. And also 4.45. Okay, so I don't know whether you realize or not. Actually, for all the discrete random variable, the value of X that I can take are always integers. Alright, like binomial is from 0 until n, but you can only take the integers value. Alright, the same thing happened here. X is between 1.55 until 4.45. So what are the integers that is between 1.55 and 4.45? So you have 2. Okay, you should have 3. Then X can be also 4. Alright, so please calculate the probability here for X equals to 3, X equals to 1, X equals to 2. And then after that again, you try to complete the steps and try and see whether you can get 0.700 significant figure. Alright, so this is what you have for binomial distribution. Okay, so again, as what I mentioned before, for those who are from SPM, I believe that you might find that this is very simple for you. But again, train yourself to identify the question that it belongs to binomial distribution. Alright, you'll see that when they mix everything together, it is sometimes not so easy for you to detect the binomial distribution question. Okay, right? So here we ended our binomial distribution part. So for the next video, we are going to discuss another distribution, which is geometric distribution. Alright, so please make sure that you can handle the binomial distribution very well first. Alright, then later only we focus on geometry.